Hi, this is Purnima Magalingam and you're watching video lecture series on power system protection and switchgear. Today in this video we are going to discuss about the apparatus protection, so mainly the protection of transformers. Come, let's go to the video. Here comes first why the transformer protections matters. Yeah, main thing. So why the transformer need to be protected? Because the transformers are the costly and critical assets in power systems, so which representing significant capital investment that can reaches millions of dollars. When the transformer gets fails, the consequences cascade throughout the networks. So the transformer fails causes major outages and expensive repairs, with outage impacts of worth worse than transmission line fault. The ripple effect can affect the thousands of customers and critical infrastructures. Here the fun fact it is the large power transfers can weigh as much as the small elephant, up to 400 tons. So main thing, it should be protected. It is costly and it is a critical asset in power system. And now coming to the common transfer faults and causes. Here we have an internal fault, external fault, the mechanical failures and environmental causes. So it is categorized into four type. And internal fault, where what about the internal fault? It is or a short circuit, turn on, turn off fault, and core fault represents the most dangerous failures modes. And what about the external fault? When the external fault it is when it is overloaded or overloaded, short circuited and connected transmission lines can stress the transformer components, etc. So this comes under the external faults. Coming to the mechanical faults, what happens is the tap changing. So when the changing, the tap changing fault and the brushing failures due to the mechanical wearings and agings. And main thing is in environmental causes, so insulation breakdowns, oil contaminations, and overheating from thermal stresses. So these are the main causes and faults or and transformers. Here comes a curious hint. It is study shows 51 percentage of the failures are winding faults, makes them that the one of the main, that is first and major enemy. So winding fault is the major enemy. Okay. Coming to key protection principles, we are categorized into four principles here. One is rapid fault deductions, and the next one is fault discriminations. Next one is selective protections. Next one is multi-parameter sessions. So here comes what happened. It is coming to the rapid fault deductions. What happened? It is detect fault quickly to minimize the damages and downstreams and speed of the criticals. That is every seconds counts in preventing cascading faults. So coming to the fault discriminations, so differentiate internal fault from external systems to fault, ensures accurate responses and avoid unnecessary shutdowns. And selective protections, uses selective protection schemes to isolate only the fault equipment and maintain service to unaffected area. And multi-parameter sensing means, example, it is it's a combination electrical sensings like voltage, current, with mechanical parameters like temperature, pressure, gases for compensative monitoring. So it has a multi-parameter sensing. So here coming to the key formula, we know that the fault current magnitude depends on the fault location and transformer impedance. So fault current, it is a rated voltage divided by is a transformer plus is a source. Is a transformer, is the impedance of the transformer and impedance of the sources. This is the key formula for here. Now coming to the differential protections, that is the example of 87T relay, and how it is currents. Compare the currents, protections, internal faults, and install tripping. Install stripping. Here how it is work is the relay compass the current entering and leaving the transformer winding using CTs on both primary and secondaries. It compass the current of incoming and outgoing, and this sophisticated approach is sensitive that to internal fault, it immune to extend the fault as this can detect turn on and turn off and face to face fault inside the transformer with exponential accuracy. So what happens is this, how what is it compares the both primary and secondary side current for internal fault. These types of relay 87 T relay, differential protection. Here comes the overcurrent and earth fault protections. Here we have an overcurrent detection, earth fault sensing, and backup. So overcurrent, the relay detect overloaded and phase fault monitoring current level continuously. So it detects the over voltage and it monitors the current level continuously to avoid the overcurrent. And earth fault sophisticated relay detect ground fault using neutral current transformer. Backup protection is often used as a backup or for a smaller transformer, which cost in factors. And the coordinating with the upstream and downstreams protecting device is critical to ensure and selective tripping for that. Here coming to the Buchholz relay. So we can see the Buchholz relay is a mechanical device that detects gas accumulations from internal fault or providing early warning of installation failure or arcing with oil filling transformers. Buchholz relay is important relay and gas detections. So installing the piping between the transformer and the tank. It is installed between the transformer and the tank conservation. It trips the circuit breaker if the dangerous gas level or oil gas are detected. Here the curious hint, it is a name named after Max Buchholz, who invented it in 1921, over 100 years of reliable service. This relay is kept because who identified this relay, that is what Buchholz identified this relay. So this relay is called as Buchholz relay. So coordinating and selective protections, we have a zone protection, time gradient, and secondary testings. We have the main these thing, and we have a time delay formula. So time t equal to k into internal fault by pickup current, internal fault current by pickup current. So k is a multiplex setting and value. So multiplexer setting value. Here comes the coordinating and selective in protections. So which zone we are going to protect, and time gradient, how many time it need to be tripped only after downstream device to fall to the clear fault. And secondary testing, so includes injections testing and simulate of fault condition to verify the settings. Here coming to the handling magnetizing inrush current. So the inrush challenges and harmonic resultant. So harmonics here plays a major role. So what about here inrush current and harmonics resultant? Here the modern relays are used second harmonic detection to block tripping during energization, avoid algorithm analysis frequency and content to prevent fault operations, etc. So here coming to the inrush current, so occurs when a transformer energized reaches 8 into 30 into rated current, and differential relay must distinguish there from the actual fault current. Here the fun factor is transformer inrush current can create mechanical vibration louder than a rock which exceeds of 100 decibels. And finally we came to the summary. So here we have seen the multi-layer approaches, speed is critical and regular maintenance. Or what about the modern technologies? We have used digital relay with advanced algorithm for superior accuracy and diagnositions. The speed is critical, so prioritize fast detecting of internal fault to prevent castrologic damages. And regular maintenance is important. Testing and maintenance can improve protecting reliability and extend equipments. Here coming to the combined multi protections methods for compensative coverage and redundancy. So these are the thing. Here remember, the protecting transformer protects the entire power system's healthy, safety and reliability. So every protection discuss impact thousands of customers and critical infrastructures. I hope you understood this topic. We will meet in next class. Thank you.